This is Precalculus concept 33D. We're going to talk about solving trig equations again by factoring, but be presented with a few examples that are a little bit different than the quadratic type of factoring. So let's start off with an example. Tangent of x times sine squared x equals 3 tangent of x is our problem. And again, our goal is to solve, which is what x angles in the region from 0 to 2 pi are solutions to this. So what a lot of people want to do is divide both sides by tangent. And that's a very common instinct to have. It makes a lot of sense. But it's actually an incorrect thing to do. So you want to make sure you don't do this. The reason why is that sometimes that function can be 0, and we never want to divide by 0. So while you can divide both sides of an equation by a number, you never ever want to divide both sides of an equation by a formula or a function. So I'm going to erase that and actually think about a different approach. Turns out to be very similar, but what I want to do is group everything on the same side of the equation. And then instead of dividing out the tangent, I actually want to factor it out. So it's a similar idea. I want to kind of get rid of the tangent, but we don't want to have it disappear. We want to have this left over. Okay, and so this is what I get when it's factored. Now it's resembling kind of that quadratic type expression where I have two factors. I can set each one of them equal to 0, and you end up with two relatively simple trig equations. Let's start off with the left one. If I have a tangent equal to 0, remember that means that the sine over the cosine would have to equal 0. And that's actually the same thing as saying the sine x equals 0. So we should be thinking about kind of this angle and this angle as the two places where that happens. And my solution to this part of the equation then is 0 and pi. Some people put 2 pi also, and that's not wrong, but notice if we go back to the beginning and the constraint given, we actually don't include 2 pi because that's really the same angle as 0. So in one trip around the circle, we start at 0 and we stop just short of 2 pi. So really I just have two answers to that. Okay, second half is solving for this. I would need to square root both sides, and I would get sine of x equals plus or minus the square root of 3. So this is one that, although it looks like a special angle value, like root 3 over 2, it's actually not. And if you think about it a little bit further, we've talked about the sine function always being between -1 and 1. And while I don't know exactly what 3 is, I definitely know that it's more than 1. So it turns out that there is no solution to this half of the problem. Okay, so my final answer is only 0 and pi. Just to summarize the strategy, you want to basically move everything to one side of the equation, set it equal to 0, and then instead of dividing out a term, you want to factor out a term. Alright, let's look at another example. These can be a little tricky, but this one, you already have everything on one side of the equation. While you might be tempted to divide by sign, you don't want to do that, but you do want to factor. So I'm going to factor out a sign. I'm left with a 1 plus 2 cosine, and this is the stage where I now have two simple trig expressions to solve. So either the first factor, sine, is equal to 0, or the second factor, which is 1 plus 2 cosine x equals 0. Cosine x in this case would be -1/2, and from our previous lesson, we should be able to think about where and what the solutions to each one of these little mini problems is. This one's going to be 0 and pi, so those are two answers. This one is going to be a second quadrant angle and a third quadrant angle whose cosine is -1/2. Pull out your unit circles for help. 2 pi over 3 and 4 pi over 3 are my answers to this one. Okay, so in the end I had 4 separate answers to this original problem. Alright, here's a U-try. It's actually a lot like the first one. Take a couple minutes, think about the appropriate way to factor and solve this, and give your answers in the 0 to 2 pi window. Alright, hopefully you started by moving everything to the left side of the equation, factoring the expression, not dividing sign, but factoring it out, and then getting two simple trig equations. One of them had answers of 0 and pi, and the other one had answers of pi over 4 and 5 pi over 4.